Okay, Bismillah. Guys, you people have been adding and subtracting vectors a lot. You even have been multiplying the vectors with the scalar quantities. Like if there is a vector which is, let's say, 2, 3, minus 4, and you know how to find 2 into this 2, 3, minus 4. This is called the product of a vector with a scalar. Okay, so this is going to be 4, 6, and minus 8. Okay, and then you also know that um, this like this AB is written as OB minus OA. So that is done through the addition of vectors. Now I have to tell you about the vectors multiplication. When we talk about the vectors multiplication, then we have two kinds of these multiplications, these product, okay? Vectors product, okay? One is called the scalar product, and the second is called the vector product, okay? Now, the scalar product is, this is written as, this is going to be cos theta, that is equal to um, A dot B, where A dot B, this cap on A and B means the unit vectors of A and B. The vector product means that is written as sine theta, that is equal to A cross B. You know that this dot and cross both mean the multiplication, but here they are going to determine the difference between the dot product and the cross product. Okay, so this scalar product is also known as the dot product. Okay, and this vector product is also called the cross product. Now, luckily for you people, this cross product is no more in your syllabus. This has been moved into the further mathematics. Okay, you only have to learn that how to perform this scalar product. Okay, so now by looking at this cos theta, that is A dot B, the scalar product basically depends on the angle between the vectors that you people are multiplying. Now suppose if you if you recall that, like, you know, the vectors in 3 dimensions, we have like this, and then there is a third dimension over here. Okay, this is your x-axis, here it is your y-axis, and this one is the z-axis. If you look at the corner of the room where you might be you're sitting, you will see that all three of these directions, they have a right angle between them. Okay, there is a right angle between the x-axis and y-axis, the y-axis and the z-axis. This can be one of the walls of your room. Okay, and this z-axis and x-axis, that can also be another wall of your room. Okay, so since you have a right angle between the x and y axis and all these three axes, so you see that if you have a unit vector in this direction, which is I, and then a unit vector in this direction, which is j, and a unit vector in this direction, which is going to be k. Now tell me, can I say I dot j is same as j dot k is same as I dot k? They're all equal to 0 because they have a right angle between them, and I'm going to put them equal to 90. So that is why they are all equal to 0, because you know that cos 90 is, cos 90 is, yes,
Zero.
cos 90 is 0. Now similarly, if you have, like, for example, if this is your y-axis and this is your x-axis, okay? Now, suppose you have, here is, this is your x-axis. Now, this is 5 and this is 2 over here. Let's say this is O, this is A, and this is B. If your OA is 2i, okay, your OA is 2i or it is 200, I'm going to write it as 2i, okay, and your OB is going to be 5i or 500. I'm going to write it as 5i. Can someone tell me what will be the angle AOB from A to O and then from O to B? What is this angle? Yes? Come on, yaar. What is the angle AOB? That is 0. Come on. Like if you have A over here, this is your O, this is your B. So this is your angle AOB. If OA and OB are overlapping, like you have A here, you have B over here, and this is your O over here. So what is the angle AOB then? Yaar, jaldi bola karo. Now what is the angle AOB?
Zero. Zero.
That is going to be 0. So that is why you should allow me to say that if you have I dot I, because they are both in the x direction now. I'm writing here I dot I. Now, if one of the vectors is 2 units, the other is 5 units, and let's say one is 10 units, the other is 7 units over here, would that change the angle over here? Like if this is A, O, this is A, and this is B. So the
No,
length
sir.
of
What?
the arms is not going to change the angle between them. That is why we use um, these are the unit vectors. We are not interested in the lengths of the arms of the angle. So we just use the unit vectors. That is why I'm just writing I dot I. That will be equal to J dot J, will be equal to k dot k, and they will all be equal to cos 0. And you know that cos 0 is 1. That is why you will have this fact over here that I dot I, that is same as j dot j, and that is same as k dot k. So that is equal to 1. Okay. Now suppose you have a vector which is 2i plus 3j minus 5k, and you want to perform the dot product with this. This is 3i minus 2j plus 4k. Okay, so now you have this in your mind that I dot I, j dot j, and k dot k, they are all equal to 1, and I dot j, j dot k, and k dot I or I dot k, they're all equal to 0. So when you are multiplying this, you will only be interested in multiplying this 2i with the 3i, because you will get 6 here. Okay, remember I dot I is 1. So this is 6 I dot I. So that is going to be 6. You will be interested in multiplying the 3j with the minus 2j. So that is minus 6. And you will multiply this 5k with the 4k. So this is minus 20. So their dot product is going to be equal to minus 20. Okay? And you don't need to multiply this 2i with the 2j or 2i with the 4k or 3j with the 3i, because you know that when there's a combination of ij or jk or ki, their dot product is going to be equal to 0. Now, if I take you back, you see that here I was writing that this product is called a scalar product. Why do we call this a scalar product? Because you see that you have multiplied two vectors and the product is a number. That is just a number. This is not a vector. Okay. So that is why the dot product is also called the scalar product. Okay. We
So
get a
why didn't we write I with I, J, or K with the 6 minus
look
6
at
and
this,
minus
beta.
20?
Look at this. What is I dot J?
It's 0.
So then why do you want to write all the zeros here? Hmm?
Okay. ठीक है.
Okay. So now we shall be writing them in like from now onwards, I will be writing them in the matrix form, because this is quicker to multiply them or do all these operations with them. Okay. So when I have to perform this, scalar product or dot product, I know that 2 will be multiplied by 3, 3 with the minus 2, and minus 4 with the 4, because this is I wala, this is I wala, J wala, K wala, K wala. Okay, 6 minus 6, and then that is minus 20. So this is going to be minus 20. Can you quickly try this dot product? Let's say you have 3I minus 4J plus 2K dot uh, 2I plus 3J minus 5K. Yes, can you do that quickly? Let's see who gives us the answer first of all. There's 3 minus 4, 2 dot 2, 3 minus 5. That is 6 minus 12 minus,
Minus 16.
yeah, that is minus 16. Okay, let me see who tells me first of all that what is going to be 2I dot 3I plus 4J minus 2K. Yes, what is this product?
There is
Hmm?
6 with
6.
That will only be 6. Very good, because this 2I is basically 2, 0, 0, and this is going to be 3, 4 minus 2. So that is going to be 6. Okay. So that is how you perform this dot product. Okay. Now, when we are dealing with the dot product, then you see that the dot product is just another name of the cos of the angle between the vectors being multiplied. Okay. Acha. When I write this, then I should ask you that if you people know that if your theta is right angle, what would be this dot product? If your,
0.
yeah, that is going to be 0. Okay. If your theta is an acute angle, okay, and what would be this dot product? If your theta is an obtuse angle, then what would be this dot product? Okay, so you correctly told that this is going to be 0, because whenever they are perpendicular, the angle between them is a right angle, the dot product is going to be equal to 0. Okay, when they have the acute angle between them, the dot product will be positive. Okay, and when you have the obtuse angle between them, the dot product will result into a negative thing. Okay. Okay, guys, did you get this? Hannah?
Yes, sir.
Dot product wali baat. Let's try some questions from the past, from the book first, and then we shall be going on to the past papers. Okay. So I'll be sharing the book with you. Okay, these are the papers. I should go here. Okay, now this is the exercise that we were trying. Okay, so you start from the first question. Okay, you try the first question. Okay, in this first question, we have to see that if the given vectors, they are perpendicular to each other. So we have just discussed that if two vectors are perpendicular, the dot product should be 0, because perpendicular means that there is a right angle between them, and cos 90 is 0. So if I do that A part, you will see that this is 2, 8 minus 2, and then dot, this is 7 minus 1, 3. So you see that it's going to be 14 minus 8 minus 6. So you see the result is 0 over here. So that means the vector A is perpendicular to the vector B. That is your A part. If you look at the B part, um, this is going to be 5, 12, and 13 dot minus 3, minus 1, and then 3. So this is minus 15, minus 12, plus 39, minus 27. So this is going to be 12. Now this is not equal to 0. So that means they are not perpendicular to each other. So now he says find the angle between them. So we know that how to find the angle. So I would say that cos theta, let me change the color here. Yeah, the cos theta is going to be the C dot D over, there's a dot between them, over the magnitude of the C times the magnitude of D. Basically, we are multiplying two unit vectors. Remember, a unit vector is a vector divided by its magnitude. So we just found this C dot D, that was 12. So I'll be writing 12 over here. And then um, I think I haven't told you how to find the magnitude of a vector in 3D. If you remember that when there is a vector in 2D, the magnitude of this vector is going to be the square root of x square plus y square. Similarly, if you have a vector x, y, z, then its magnitude is going to be, it is going to be x square plus y square plus z square. So that is how you have the magnitude of this. C is going to be 25 plus 144 plus 169, okay, times the other one is going to be 9 plus 1 plus 9, okay. So now you have to use your calculators. This is 12 over under root, this is 338, I think, 338 times, this is 19, yes, I guess. So who will tell me what is cos inverse of all of this? You can give your answer in degree.
81.4.
Yeah,
81.4 degrees.
81.4 degrees. So that is how you find the angle between two vectors. Now, in the next segment, I'll be taking you to the some past paper questions, and you will see that how you can use this dot product to determine the angles. Okay.